Okay, so here we are in module 3. What I wanted to do is get a little bit deeper into the project. We introduced it the last time we were together, but I know that some questions have come up, and I know that since you've gone through the original practice problems, you've got your feet wet on some of the basics or the fundamentals of sheet metal, but there are a couple options in there that might come in handy as you create your CanCrusher. So I'm going to go underneath our camera for right now. And I know it virtually, for those who are out there, it might not be the easiest, but you kind of get the idea. We're going to be looking at reverse engineering this CanCrusher, okay? And it's not intended to be a full duplication of or exactly what you see here. This is kind of like our foundation of what I want you guys to, achieve in the end. So last time there was some students that got a chance to start reverse engineering. So you are going to be measuring. You're going to be kind of figuring out, what parts, how much clearances there are, what the fit should be, that type of thing. You're going to do the entire design process so that it is going to work, okay, as we see it here. Now, additionally, as part of your assignment, there are design changes that I want you to make. I want you to look at this not so much as let's duplicate what's here, but more, what are some improvements that we can make in order for this to work better? Maybe it's experiences that you've had with your own CanCrushers that you're like, oh, it'd be cool to have this, that, or the other. Maybe it's, making it taller. I kind of like heard somebody say that earlier, like to maybe accommodate some of those energy drinks that are taller cans, because in this one, I don't think it would quite make it tall enough. So yes, to absolutely extend things, make them longer so that you can, accommodate some of those other sizes is a design change. So I want you to be thinking about that. When you turn this in with design changes, that's your one turn-in submission. So it's not like you have to duplicate this the way it is and then submit revisions. I just want you to use this as a basis of the functionality of the parts that you're using. I want you to apply sheet metal parts to this, but then you can expand, like I said, and make it your own with some design changes that you think would make it better. Maybe putting a bucket on the bottom or some sort of a catch, that would maybe catch the crushed cans or the tops of bottles that might be opened. I don't know. So use your creativity, but I'd like you to come up with 3 things. So one can be relatively simple. I know somebody asked, well, what if I change the material thickness? Is that a design change? Yes, but that would be one. Even though there's multiple parts here, that's one design change because that's pretty easy, you know what I mean? And pretty universal. But then if you do some of the other things, that would be an additional. So I'd like you to come up with 3 on here, okay? And that can even be in redesigning the little handle here, the shape of it, stuff like that. So just check with me as you're trying to decide if it would be something that would be appropriate or not, or if it would count. So questions on that? Questions on that? Okay. All right. Then what I wanted to do was, somebody asked earlier as well about sheet metal gauge. There are standard sheet metal gauges. So when sheet metal comes, it's going to be literally in large sheets, and you are going to then laser cut or punch out kind of that flat layout that we had seen in the part that you did for your actuator bracket. And then it's going to be put on a press brake, and it's going to be bent in the areas and the dimensions that you give. So the thicknesses here are standard that you would actually buy out in industry. Now, I don't have a list of them because it's very widely available. If you just do an internet search of standard, sheet metal gauges, you're going to find what the gauge is. So for instance, there's like 12, 13, 14, 15, 16 gauge, all that kind of stuff. And then that equates to a thickness. So when you determine how thick one of your parts is, then you want to look on a sheet metal, a standard sheet metal gauge list, and you want to translate to what the gauge is going to be. Now, keep in mind that there are finishes on here. So these are painted, so that's going to add a little bit to the thickness. So if you're finding that, ooh, this is a little bit thicker than this gauge or thinner than that gauge, you probably are going to be on the thinner gauge because there's also a layer of paint that's on here as well that is adding to your dimension that you're reverse engineering. So keep that in mind. So when you specify and when you put the material into your title blocks, you do have to specify the standard gauge. Okay, so keep that in mind. So that was one question I wanted to answer. As we look at the parts, you are probably going to notice that for the most part, I call this kind of the base. Okay, so this is like what attaches to the wall. This whole piece you can do with what you learned out learned out in industry. No, what you learned in the tutorial. You have everything that you need there. The part that I wanted to talk about was this bottom piece, because this has a little bit different command that we can use. In the tutorial, you guys used the planer, the flat, and the bend, I think, right? Those were the three. But this, because this is a part that, this is a flange going all the way around, we can't use those, okay? So there is another command in there called the flange. And so I want to show you how to use that and how, if you wanted to use this very same form, how it's going to work on there. So I'm going to show you that today. And then additionally, I wanted you to show how you can get, I think the easiest one to see here, these like forms that are in here. You don't have to put those in if you don't want to, but what they do for sheet metal parts is it stiffens them up. It's kind of like cold hardening them, work hardening them. And what happens is the parts become stiffer, so that if if you get some major force here, that this isn't bending. Okay, so it makes the parts more stiff without adding additional material. So so I wanted to show you how we can incorporate those forms in there as well. So the part that I'm going to pull up is going to be this bottom one. And I'm just going to do a quick demonstration of those two commands, and then I'm going to let you guys work or ask any additional questions that you might have. So so I'm going to go down, and I already have kind of this started. So this is that bottom piece, and this is 420, I think, is the part number that I assigned for it. So make sure that you're looking in the part models assignment for assignment number 3 to get what the numbers are in the corresponding parts. If you have questions on those, let me know. I kind of gave part numbers for them, but if you do some design changes and you want to change that up a little bit, that's okay. So we want to create this flange going around the whole outside here. So I'm going to back this up. And the first thing you want to do, and it is an important part, is you want to make the sheet metal form around the perimeter here. So as you do your reverse engineering, this radius on the front end, just make it look good. That's part of this. You're not going to have the ability to know exactly what that radius was. When I created mine, I think I did a radius of 6. So on this this like center plane, I put the center line for that as a diameter of 12, and then that it was tangent with the end part here. And I just kind of was like, oh, that looks pretty good. So that's what my radius was. So you don't want it to be too shallow, but you don't need it to be too large. So reverse engineering, kind of making it look good. So here's that radius there. And then the back sides is just kind of a rectangle looking at the top here. Again, reverse engineered that with a scale in this case. I didn't even use calipers or anything, just kind of like what that top portion was like. Then you'll notice, I want to call this to your attention here. We have to have the radius on the end here. We're going to be seeing a function when we get into the flange tool where it's going to be looking for tangencies. If this is not a radius here, it's going to stop on the corner. Okay. And we want it to round the corner. We want to go around the tangent edges. So, so that's going to be one of those. And that's one of the shapes that is in the front here too. There is a radius on the front. So it's really kind of reverse engineering or duplicating what's there. So once you have your sketch all set, feature requirements look good, we're going to hit OK. And that was my planer. And I made this, I believe this was a 1/16 of an inch, or yeah, 1/16 of an inch, which is, I believe, 16 gauge steel. That's like a standard, one of the standard gauges. So now that I have this here, I want to now make that flange over the edge. So we are going to go into the flange command. Okay. So I'm just simply going to go into the flange command, not flat. And now it wants me to select. Okay. So what I'm going to do is I am going to select the edge that I want it to be on. Now, for right now, it is only on the one edge. So what I want to do is I want to go into details, and I want to click on rule based up here. And then you're going to notice that there's an option for tangent. Okay. So want to make sure that that is there. That's the only one that I want on there. And then you're going to notice over here, so I'm going to kind of pull this over, that it's going to start where this yellow dot is. It's going to come around and it's going to end back here. It does not use the back wall because it's not around a corner there. There's not a tangent edge there. That's why if you leave these as like squared edges, even though they're going up to a radius and they're not rounded, it won't recognize that as a tangent edge and it'll stop there. Okay. So make sure you have those radiuses on there. And then you just can hit OK. And then what's going to happen is you are going to find, why the heck didn't it close? Did I do something wrong? Tangent edge rule based. Why didn't it close? I just did it. I'll look in just a minute. Oh, Creo, make me so mad. Well, anyway, to get the depth of how deep this is going to be, you're going to notice that there is a dimension right here. So you can just double click it on the screen. And I measured mine, I believe, to be 0.25 going down. So now we got to figure out why I don't have that radius in the front. Oh, because of the thickness side. Yeah, because I had it to the inside rather than to the outside. So if you remember from our tutorial, this is where it goes to the inside of the edge that you created, or if you go to the outside. Going to the outside makes it around the corners. So so make sure that you do that here to create that right radius around the flange. So if you do have that problem, make sure it's there. So now you've got then a consistent flange going all the way around, okay, your part on the 3 sides that you need it to be. So I'm going to hit OK. So what I've accomplished here is if we look underneath the camera, I've accomplished putting this flange all the way around the part. Now, to get this portion right here, you would simply add a planar wall to the top of that. Okay. So, so to do that, and I'll just kind of briefly do that. All that you're going to do is you're going to add a planar, you're going to add it on this surface, and then you're simply going to draw the shape, adding your dimension. And again, you're going to be reverse engineering this to your best of ability, and then doing a line across the bottom. And again, I'm just, kind of being very crude about this right now, just to give you a demo. You are going to be filling in how tall that's going to be off of the flange. I'm not going there right now, so don't worry so much about that. And then I'm just going to check my feature requirements. I look good. Okay. And then that adds the thickness to the side there. Okay. So then now you have that portion in there. You can do now a mirror to get it on the other side. And then you can do an extrude cut to get the hole through, to actually attach it at the bottom. Okay. So I'm not gonna finish the other side. So any questions kind of about getting that form in place? Okay. So flange is really the new thing there that we didn't experience before. And then making sure that that thickness is on the correct side. So the other thing that I wanted to show you on this very same part is going to be, how do we get those forms in there? So again, this form is in here to create stiffness on our part and strength. So, so I'm going to go back over here, and we want to do this using the form tool, but we're going to go to sketched form. I found an easier way in class the other day, the way that I was, that I had seen it in the past done in other softwares, as well as in Creo, was always the punch and the die form, where you have to actually create external features or external parts to actually create that form. But they have the sketched form in here for what we see here. So this is actually, I think, an easier way to go about this. So we're just simply going to go into form, sketched form, and then you're going to select the surface that you want to sketch on. So it's going to be this top surface right here. And then now you're going to sketch the form that you want to put on here. I'm going to keep this simple. I'm just going to put a line, and I'm going to make a rectangle on here. There we go. Something like that. It's not even a rectangle. It's not very good. And I'm just going to have my form here. You would, if you wanted to duplicate what was here, you would take some measurements. You would kind of get the idea of what's there. So this is going to be like my form on that surface. I'm going to check here. I look good. I'm not going to worry so much about the dimensions. Now, this is the form that I have. Now, right now, it is assuming that I want to form this, you know, outside. So when I look here, it actually indents from the side that I'm on the top. So all I'm going to do is I'm going to switch the direction right here. So it would go down. I also can change the depth here. So you can kind of, you know, look around. I'm going to say it's, I don't know, 32nd of an inch, 0.03, oopsie, 3125. And you're going to notice that it changes then the depth there that we have. Okay. Now you'll also notice on the part there are rounding of edges, which is very typical of this type of work. So I'm going to go into options. And this is where I can add tapers and I can add radiuses as well. So I'm going to add a taper and I'm going to say 45 degrees. Okay. So you can see, you can right here, it does it on that side where it goes in, but it also does it on the back side too. Okay, so I put 45, you can do 30, you can, whatever you want. Okay, whatever to get the look that you're interested in. And then lastly, you're going to notice that you have options here for rounding the corners. So this is the non-placement edges. No, I'm going to leave that. I think it's going to be half the thickness. I think the radiuses on the inside are just a little large for the thickness. My thickness is only a 1/16 of an inch. I only had this go down a 32nd of an inch, so it can't put in a 1/16 of an inch radiuses in there. That's why it kind of, you know, gave that or didn't show it. And then you can do the placement edges as well. And again, probably do something smaller or specify something smaller. Inside, it might be outside. Or take them off because they're also rounded there. So play with that a little bit. And again, it's going to have to do with how deep you go or how shallow you are. Your radiuses may or may not come out to exactly half the thickness or the thicknesses. So again, that's what's there. I mean, I did to put those on there. Maybe if I make it a little deeper. Well, it doesn't want to cooperate right now, but I got mine to work before. So once you have that in place, okay, then you can hit OK. And then you're going to notice that it adds that, you know, top and bottom, and then mirrors those same radiuses on the back side as well. So, so that would be how you could get those in. So the parts that have those types of forms on them, if you wanted to, you know, duplicate or try some of these things, is going to be this base part. I think I call this the crushing part, the top. And then also the sides of the handles have those, you know, those in those as well. Okay. So when I created my full assembly, I just duplicated what I felt was here and was able to get those in. So flange command, the stretch form, play with that. And then I was going to show you also my assembly. So I'm gonna open up my assembly. This is 400. So I basically, I'm gonna put in quotes, duplicated what was here. I really didn't deviate too much, just to show you kind of what is what. And so you'll notice that I did do the sketched forms around. The only thing I didn't have add yet was my handle, you know, the actual outside of the handle, but this is the inside portion. And then part of what I also want you guys to do is to create an animation. Okay, I decided to make that extra credit. I don't have it as an assignment. I'll add it as an extra credit, but I will tell you that to do it, all of the parts you can put in normally. You don't have to add like slider or anything. I originally used a slider on this top part, but when I did it again, I found that I didn't have to do it. So I just did a regular assembly. The only one that I did do as a pin was down here where the handle attaches to the outside frame. Okay. And then went about that. So, so you can then add animation to this to go up and down and make sure that everything works together. Okay. The other thing I did want to mention is I did put the rivets in here, but they're not, I'm going to, again, go in quotes. They're not official rivets that are rolled over based on the manufacturing process. What I did was I went out to McMaster Carr. I found the dimensions for a rivet. And then I placed them. So they really just have a head and it's going straight through. So I did the rivets that would fit in. I think all of my holes are 1/4 of an inch. And I did the 3/16 rivets, the diameters that would fit into all of those holes, and made it simple. And that's really rivets. That's what exactly they are. Just make sure that your hole, I use 1/4 of an inch for all of my holes because the head of the rivet is then larger on the one side, and then it'll dimple in and it'll, you know, roll over so it'll attach. So I just added those that way without, again, rolling them over like they would be in their final form. But then I created a part number for each one of those so that in my assembly, I'll be able to, you know, have it as a part number and such. Okay. Questions. Those are kind of the highlights that I was thinking of that I wanted to make sure as you're getting started, these are, you know, elements that you might have questions on as you're getting going. Right now, does anybody have any questions as you're working? Okay, I'll check the chat box over here as well. Doesn't look like it at the moment. Okay, so I think for today, that's enough. Next week, when we get together, we can start looking at more specifically, probably the animations, getting the movement in here. Some of you, I imagine, will want to do it. Others, it may depend on how much time you have. That's okay too. I am going to make it extra credit because I think it's fun to do and it's good to see. So if there aren't any questions right now, then the rest of the time is work time for you guys. And I'm here to assist and answer any questions that you might have. Okay.